now we know how to calculate our derivative using the formal definition of the derivative and using the alternate definition of the derivative. However, both of those are a little bit cumbersome, and today we're going to start looking at a bunch of shortcut rules for finding derivatives. And really, for most of the rest of the year, these are what we're going to use rather than that full formal definition. These rules will come from the formal definition. I may show you one or two derivations of those. But for the most part, we're going to stick with using these new rules we're about to develop. This is section 2.2, Basic Differentiation Rules. And to get us started, we have what we're going to call the constant rule, which says the derivative of a constant equals. So first of all, I'm using my operator notation that I don't think we've used yet, but I introduced on the first day of derivatives. This symbol just means we're going to find the derivative of the thing inside there. Constant rule says the derivative of a constant is, well, we'll figure that out. Let's say I have the function f of x equals 6, or y equals 6. Y equals 6, that's a horizontal line. What's the slope, the derivative, of any horizontal line? Hopefully, you said 0. F of x equals 6 is just 1, 2, 3, 4, 5, 6. It's just a horizontal line like that. I think the slope everywhere of that thing is 0. It wouldn't change if I made this f of x equals 5 or f of x equals negative 3 or whatever. The derivative of any constant is 0. And that's our first basic differentiation rule. Derivative of any constant is 0. Next rule, which we're going to call the x rule. The derivative of x. Okay, well, f of x equals x, y equals x. That's a slanted line with a, well, I'm not going to tell you what the slope is. You're going to tell me what the slope is. What's the derivative of the function y equals x? What's the slope of y equals x? I hope you said 1. Derivative of x is just 1. Y equals mx plus b, our slope is 1, our y-intercept is 0. Not super interesting yet. Now, the power rule, and this is a big one. The power rule says, if I want to do the derivative of x raised to the n, this is going to equal n times x to the n minus 1. The derivative of x to the n is n times x to the n minus 1. Let me show you how we can use this. Later, I'll show you where this comes from. Let's say f of x equals x squared. According to our rule, f prime of x should equal, well, what was in the power, that was n. N goes out front. So I'm going to say 2x to the, I'm going to then subtract 1 from what I had in my power, to the 2 minus 1. My derivative is going to be 2x. What this formula is really saying is I'm going to take the power, I'm going to move it out front, and I'm going to subtract 1 from the power. So the derivative of x squared is 2x to the first, or just 2x. That's it. We could have done that with our formal definition, but this is going to be our shortcut we're going to use. Let's say that f of x equals x to the 5th. F prime of x equals, see if you can do this. What's the derivative? I'm going to pull down the power, 5. X to the, subtract 1 from the power. 5 minus 1 gives me 4. The derivative of x to the 5th is 5x to the 4th. Next, f of x equals 1 over x. I am not allowed to just like use the x rule over there because it's not just x, it's 1 over x. What I want to do is I want to try to rewrite this in a way that will let me use the power rule. How could I rewrite this? Well, rather than dealing with this, how about I say f of x equals x to the negative 1. Then we can go do our derivative. F prime of x is going to equal, okay, pull down the power, negative 1, x to the subtract 1 from the power, negative 2. Now, we're going to make our rule. Let's not leave negative exponents in the final answer. So I'm going to say this is negative 1 over x squared. The derivative of 1 over x is negative 1 over x squared. Let's try this one. F of x equals the square root of x. Is there a way we could rewrite this so we can use the power rule? Hopefully you thought that we could do f of x equals x to the 1/2. How about you take a moment and try to find the derivative of this? If you're watching on Edpuzzle, it's going to pause while you try to do this. F prime of x equals, pull the power down, 1/2, x to the, subtract 1 from the power. 1/2 minus 1 is like 1/2 minus 2/2, or negative 1/2. I still have that rule of not wanting to leave negative powers, so I'm going to say f prime of x equals 1 over 2x to the 1/2, or I suppose I could say 1 over square root of x. I don't care fraction powers or roots, either one is fine. What I do care about is no negative powers. And that's our power rule. We may prove that later, but right now I want to go on and show you a couple other rules. Next one is called the constant multiplier rule. The constant multiplier rule. Which says if I want to do the derivative of a constant times some function, I can just take that constant, move it out front before my derivative, and I can do c times whatever the derivative of f of x is, c times f prime of x. And that's our constant multiplier rule. Let me show you how we're going to use this. Let's take a look at the function f of x equals 5x to the 5th. If it was x to the 5th, we would just use our power rule, but because there's a number up front, I'm going to go and use that constant multiplier rule, which says I'm going to get f prime of x equals, well, I'm just going to leave the 5 up front, 5 times. Now I'm going to go do my derivative of x to the 5th. I'm going to pull down the power and subtract 1 from the power, so I'm going to get 5x to the 4th, which is just 25x to the 4th. No, I don't have to see the step in the middle. You go straight to 25x to the 4th. Totally fine. What if we have f of x equals 4x squared over 3? Hopefully, you could rewrite this as 4/3 t, I don't know where I got a t from, sorry, 4/3 x squared. Take a moment, find the derivative, and in Edpuzzle, you're just going to submit, oh, you know what, never mind. I'll do the whole thing, find the derivative, and see what you can do. So 4/3 times 2x to the 1st, or 8/3 x, or 8x over 3, or some version of that. F of x equals 1 over 2 times the cube root of x squared. First thing I want to see if you can do is rewrite this problem so I can use the constant multiplier rule and the power rule. How would you rewrite it? So I'm going to say 1/2 x to the, okay, cube root of x squared on the bottom is going to be x raised to the negative 2 thirds, like that. Take a moment, find the derivative. Let's see, negative 1 over 3 x to the 5 thirds. Should do it over there. And that's our constant multiplier rule. Next, we have our sum and difference rule. Sum and difference rules. Which says the derivative of f of x plus or minus g of x. If I want to do the derivative of a sum or a difference, all I have to do is the derivative of the first part plus or minus the derivative of the second part. It's kind of like we can distribute the derivative in this case. In general, no, we can't do that. But I'm going to get that. F prime of x plus or minus g prime of x. And the point is, this now lets us deal with more complicated functions like entire polynomials and not just monomials. F of x equals x squared plus 3x minus 1. To find the derivative of this, we just have to do the derivative of the first part, the second part, the third part. See if you can go find your derivative. F prime of x is going to equal derivative of x squared is 2x to the first, or just 2x, plus 3 times the derivative of x by our x rule is just 1, and then minus 1, well, the derivative of a constant is 0. Your derivative is going to be 2x plus 3. Next, let's take a look at f of x equals x squared plus 2 times x cubed minus 4x. F of x equals x squared plus 2 times x cubed minus 4x. I have not yet given you the product rule for derivatives, and it is not as straightforward as the derivative of this part times the derivative of that part. So we can't use that. We know very little so far. We know our constant rule, our x rule, our power rule, our constant multiplier rule, our sum and difference rule, and that's it. Is there some way we can use algebra to rewrite this so I can use the basic rules I already know? Hopefully you're thinking foiling or distributing this thing. If we do that, we're going to get f of x equals x to the 5th minus 4x cubed plus 2x cubed minus 8x, or f of x equals, I'm going to combine like terms now and get x to the 5th minus 2x cubed minus 8x. Well, now we need to go actually find the derivative of this thing. We just rewrote it. That was just the algebra part. Now we need to do the calculus part. Please try to find the derivative. Okay, pull down the power, 5x to the, subtract 1 from the power, 4th, minus pull down the power, 2 times 3 is 6, x to the, subtract 1 from the power, you get 2, minus 8 times derivative of x is 1, and there we are. F prime of x equals 5x to the 4th minus 6x squared minus 8. Next, f of x equals 4x to the 5th minus 2x to the 3rd plus 3x over x squared. F of x equals 4x to the 5th minus 2x cubed plus 3x, all over x squared. Like I have not yet given you a product rule, I also haven't given you a quotient rule. And when I do, it's not going to be as easy as derivative of the top divided by the derivative of the bottom. So we need to use some algebra to rewrite this. What I'm going to do is I'm going to go and separate my fraction. So I'm dividing each of those pieces by x squared. 4x to the fifth over x squared minus 2x to the third over x squared plus 3x over x squared. Take a moment and see if you can first simplify that using some algebra, and then find the derivative of what you get. So simplifying should give us 4x to the third minus 2x plus 3 over x. And actually 3 over x, it's going to be easier for me if I rewrite it as 3x to the negative 1. So f of x equals 4x cubed minus 2x plus 3x to the negative 1. Now we need to find the derivative. F prime of x equals 4 times 3 is 12. X to the subtract 1 from the power is 2. Minus derivative of 2x is 2 times 1, or just minus 2. Plus 3 times negative 1x to the negative 2. Bring down the power, subtract 1 from the power. And I can clean this up and say that my derivative is 12x squared minus 2 minus 3 over x squared. What you really need to realize with this example and the previous one is we don't know a whole lot right now about derivatives. Can't do anything with a product, can't do anything with a quotient. So your only tool is using some algebra to rewrite it in a better form. Next thing we have to do is look at some trig. Sine and cosine rules. The derivative of the sine of x equals you know what? Let me see if I can figure this out from what I know about the graph of the sine of x. I'm going to put tick marks at pi over 2, at pi, 3 pi over 2, 2 pi. And I'm just going to kind of trace out a sine over here. That green is my original function f of x. That equals the sine of x. I know that the derivative, the values on my derivative, correspond to the slope on my original function. So, over here at pi over 2, what's the slope of the sine of x? Hopefully you said slope was 0, which means my derivative has a y value of 0 right over there. At 3 pi over 2, what's the slope of the sine of x, so the value on the derivative? Hopefully you also said 0 over there. Next, this slope over here, would it seem reasonable to believe that it's 1? I hope you said yes. I'm going to put a point over there at 1. If this slope is 1 at x equals 0, what's the slope going to be at x equals pi? Hopefully you said negative 1. I'm going to continue over here, 1. I'm going to trace this out, and this graph I'm tracing out is the graph of the derivative of the sine of x. Oh my goodness. What is it? What's the derivative of the sine of x? Hopefully you can see. It's the cosine of x. The derivative of the sine of x is the cosine of x. Well, let me try to find the derivative of the cosine of x, and I'm going to do it in the same way. I think you probably have an idea what it's going to be, but let's verify and make sure things are actually what we want it to be. Let's see, pi over 2, pi, 3 pi over 2, 2 pi. In green, I'm going to trace out the cosine of x. And in orange, I'm going to find the slope at various places on that original function and make the slopes my y values on this derivative. Well, over here, my slope is 0, so I need a y value of 0. Slope is 0 over there as well, so I've got a y value of 0. Slope is 0 over there, y value of 0. Over here, my slope is negative 1, so I need a y value of negative 1. Here, my slope is positive 1. I need a y value of positive 1. Oh, this is not completely what I was expecting. You were probably expecting sine x. This isn't quite the sine of x. What did I just trace out? What's that the graph of? Hopefully you said negative sine x. The derivative of the sine of x is cosine x, and the derivative of the cosine x is negative sine x. Derivative of the sine of x is cosine x. Derivative of the cosine of x is negative sine x. Let's go use this. Let's see. Oops. Pull this down a little bit. Okay. So let's take a look at the function f of x equals 3x to the third minus 2 sine x plus 5 cosine x. Actually, how about you see what you can do here? See if you can find the derivative. F prime of x equals 3 times. Pull down the power, subtract 1 from the power, 3x squared, minus 2 times the derivative of the sine of x is the cosine of x, so times cosine x, plus 5 times the derivative of cosine of x is negative sine x. And I'll just clean this up. Your derivative is going to be 9x squared minus 2 cosine x minus 5 sine x. Next thing I want to talk about, those are basically all the derivative rules we're going to deal with for right now. As we move through the rest of this unit, and as we move through other units this year, we'll add a couple more to the list. I want to go back and revisit tangent lines. Find the equation of a line tangent to, let's look at f of x equals x to the 6th at x equals 1. Find the equation of a line tangent to f of x equals x to the 6th at x equals 1. Find the equation of a line tangent to f of x equals x to the 6th at x equals 1. Well, my solution is going to look like this. Y minus y1 equals m times x minus x1. Just like it did before. We're always going to start from point slope form. x1's really easy. x1 is 1. What do I have to do to find y1? Same thing I did before. I'm going to go and I'm going to plug into my original function. I'm going to find f of 1. And what do I have to do to find the slope? I need to go and plug into my derivative. I need to go and find f prime of 1. Okay, so we have a little bit of work to do now. We need to go find f prime of x. I can do that quickly over here. F prime of x equals 6x to the 5th. And now that I have that, you need to find f of 1. You need to find f prime of 1, and then just plug in all the pieces. See if you can finish this off. So let's see. F of 1 is going to be 1 to the 6th, or just 1. F prime of 1 is going to be 6 times 1 to the 5th, or 6, we're going to get y minus 1 equals 6 times x minus 1. That's it. Same stuff we were doing before in the first section. We're just going to use our shortcut rules to find the derivative rather than the whole long formal definition. Okay, two more things I want to show you, and then this video will be done. Sorry, this is a longer video, but I didn't really have a good place to stop here. Find where y equals x cubed minus x has a horizontal tangent. Find where y equals x cubed minus x has a horizontal tangent. Well, if a tangent line is horizontal, that means the slope, or the derivative, has to be what? 0. Slope is 0. Well, okay, so I need to find the slope of this, which means the derivative of this thing, and then set it equal to 0. If we go to do the derivative, we're going to get y prime equals 3x squared minus 1. I'm going to set that derivative equal to 0. And I'm going to solve 3x squared equals 1. X squared equals 1/3. So x equals plus or minus square root of 1/3. I can do the square root of the top, which is 1. Square root of the bottom is 3. I could rationalize. I think I'll just leave it at that. But the other piece is we really should find x and y coordinates. Maybe this wasn't the best example because it's going to be a little messy, but whatever. When x is 1 over root 3, y is going to equal 1 over root 3 cubed minus 1 over root 3. Okay, so root 3 cubed is like root 27, which is 1 over 3 root 3, minus 1 over root 3. I can get a common denominator, 1 over 3 root 3, minus 3 over 3 root 3 will give me negative 2 over 3 root 3. Again, I probably should have rationalized the denominator, but whatever. I'm going to get 1 over root 3 times negative 2 over 3 root 3. That's 1 point. I think I'm not going to bother going through the calculations with the other one, but if I have negative 1 over root 3, y is going to end up equaling, I believe, positive 2 over 3 root 3. I'm pretty sure in the homework, the problems are a little bit nicer. You're not going to get roots and all that stuff. But once you find your x value, plug it in and find your y's. Last very quick thing I need to show you, only because you're going to see this in the homework, and I just don't want you to get confused. This is not going to be a difficult thing. If f of x equals x squared plus x cubed, find the derivative at the point 1, 2. I want to find the derivative there at 1, 2. Well, okay, I'll give you a moment to copy that down. If f of x equals x squared plus x cubed, find the derivative at 1, 2. My derivative is 2x plus 3x squared. And now I plug in. There's no place to plug in the y value. I don't really care about the y value. I didn't even have to give you the y value. You could have found the y value from the fact that x is 1. I really just want you to find f prime of 1. That's all I'm asking here. And f prime of 1 is 2 times 1 plus 3 times 1 squared. You're going to get 5 from that.